to today's class. Today's class we'll be looking at combined resistors. So resistors, we've talked about primary resistors and resistors in our previous classes. You can go to my YouTube channel or Facebook or TikTok, you see those videos. Today we want to look at a situation where we combine them and we're asked to look for one or two things still on electricity. Example is what I have on the board. In this circuit diagram, we are asked to calculate I, defective resistance, I, the current flowing in the circuit, I also say the current across each of the resistor, and the potential difference across each of the resistors. So, solution. How do we go about this? If you see this in the exam condition, what we do is that first of all we have to resolve the capacitors in parallel. When you resolve the capacitors in parallel, the circuit diagram will now look like this. This is 24 volts. Here is our 3 ohms. Here is the parallel resistors, RP. So how do we resolve the parallel resistors? We said that for parallel resistors, for parallel resistors that the reciprocal, we have arrow parallel is equal to 1/2 plus 1/4. What is the LCM here? That's 4. 4 divided by this is 2. 2 times 1, 2. Plus 4 divided by this is 1. 1 times 1, 1. So 2 plus 1, we have 3/4. Therefore, our parallel will simply be what? 4/3 ohms. So what we got here is 4/3 ohms. So since they are now in series, we can now say for series arrangement, we now say it is what? The arithmetical summation. So we now have that what? That should be 3 plus 4/3. Well, that means I'm looking at the one in series plus the one in parallel. This is the effective now, or the effective resistance. So that will give us 3 plus 4/3. So we still got to look at the LCM, which is what? 3. This is 3/1. That's 3 times 3, 9. Plus this is 1. 1 times 4, 4. So you now have 9 plus 4, which is 13/3. So the effective resistance is simply 13/3 ohms, or 3 whole number. Okay, 4 whole number for 12, well, 1/3 ohms. That's the answer to I. Then II is asking us to calculate the current in the circuit. So the current in the circuit, okay, this is I. Okay, II. The current in the circuit. The current in the circuit, I is equal to, current is equal to voltage over resistance. The resistance in this question is effective resistance. And that's the entire circuit now. So what is the voltage here? That's 24 volts. Divided by effective resistance is what? 13/3, which is 24 times 3/13. You just turn it upside down. You now have this will be 72. I'm having 72 for all over 13 ampere. So when you divide this, whatever you have will be your answer. Then the third question is current across each of the resistors. So you can see that the current here, because the series, the current here will be the same. The current here and here will be the same. But the voltage here and here will not be the same. So we can get the voltage here first. That means we are going to solve the IV instead. Because without the voltage, you cannot do anything. So instead, the IV will give you the voltage across the series is equal to the current in the series times the resistance of the series. So what's the current in the series? That's the same thing, which is 72/13 times the resistance of the series, which is what? 3. And you have this is 216/13. 13 what? Volts. So when you divide, whatever you have is your answer. We can also get our voltage in the parallel as what? The total voltage in the circuit minus voltage in the series. So the total voltage is simply 24 minus 216/13. So the LCM here is simply what? 13. This time 13 times this will give you, that's 240 for 10 plus 72, plus 72. So we have 312. So I'm having 312 minus this side is what? 216. So when you subtract, you have 312 minus 216. This will give you 312. This is already, then this is to give you 9. To have 96. I think I'll be having 96, okay, which is 96/13 volts. So what it means is that the current, the voltage in the parallel is 96. The voltage in the series is 216 volts. Then you can, from here now, you can now talk about the current in each of the resistor. So the current in the parallel will give you the voltage of the parallel multiplied by, so the current in the parallel will simply give us, we've done something like this here, which is current is equal to what? Voltage over resistance over voltage in the parallel. So what is voltage in the parallel? 96/13 times resistance of the parallel is what? Where is the resistance of the parallel? We got it to be somewhere here. Okay, that's 4/3. So we have it as 4/3. So this will simply give us 96/13 times 3/4. So when you divide the numerator, you have, this will give you 18, 8 carry 1. So we have 27 plus 1, 28, 288 divided by, this time this will give you 52 ampere. You can also reduce it to its lowest step, but because we're not using a calculator, we are just we're not looking at it. So we also look at the last one there, which is the current in the series. In fact, the current in the series is going to give us the same thing. So let's see. The current in the series will give you the voltage of the series times the resistance of the series. So what's the voltage of the series? The voltage of the series is what? 216/13. We have 216/13 divided by 3. So we have 216/13 divided by 3. The resistance of the series is simply what? 3. So when this divide, you have what? You have about 72. I hope you did enjoy the class. Please like, share, and follow for more. Thank you.